Let's do an example using Malus law in calculating the intensity of polarized light. So here we have a series of polarized filters, one that's oriented vertically, one that's oriented 30 degrees from that, and then you have a horizontal filter. So as you go from vertical to the second filter, it makes 30 degrees. But as you go from the second filter to horizontal, that means that makes a degree of 60 degrees, an angle of 60 degrees. Okay, so that's the setup. Now, here's the question. You have sunlight that's seen at an intensity of 1,367 watts per square meter at the Earth's surface. If this passes through a vertical polarized filter, a filter at 30 degrees, and then a horizontal filter, then we want to know what's the final intensity of sunlight. Well, the first step is to go through the polarizing filter. So that's the vertical polarizer. That's step one. Now we're going from unpolarized light to polarized light. So we're going to call this I0, I1, I2, and then I3 at the end. So we go through the vertical polarizer. We've got vertically polarized light. Since it's going unpolarized to polarized, that means that the light is only 1/2 of the intensity of the initial unpolarized light. But then our light goes through the 30-degree angle filter, thus polarizing it now at an angle. I can draw that more at an angle. There we go. And that is what we're going to call step 2. Now we're going from I1 to I2, and since it's polarized light going through a polarized filter, we have to use Malus law. I2 is equal to I1 cosine squared of the angle between the polarized light and the filter itself, which we said was 30 degrees. Step 3 would be going from I2 to I3, and there you're going from light that's polarized at 30 degrees from the vertical to horizontal, making an angle of 60 degrees like we talked about earlier. Again, polarized light going through a filter, that means we have to do Malus law, but this time it makes an angle of 60 degrees. Okay, so let's go ahead, that's the setup. Let's go ahead and do our calculations now. So the first step, we just take our intensity and cut it in half. So we have 1,367, cut it in half, you get an intensity of 683.5 watts per square meter. Step 2, you take that 683.5 watts per square meter and you multiply that by the cosine squared of 30 degrees. Cosine of 30 is 0.866. Square that, you get 0.75. So 683.5 times 0.75 is going to give us 512.625 watts per square meter, all round at the end. Step 3, you're taking intensity 2, which we just found to be 512.625 watts per square meter, multiplying that by the cosine squared of 60. Well, the cosine of 60 is 1/2. Square that, that's 1/4 or 0.25. Which means my final intensity then is going to be 512.625 times 0.25, 128.156 watts per square meter. So my final intensity is going to be 128 watts per square meter. There it is.